Now here's the model we built up last module when we talked about Marge and Homer meeting at a party and then later on conversing over the telephone. We talked about the local addressing with the names, the global addressing with the phone number, the cues, which were just keeping the conversation going, and our data, which was the conversation itself. This time I want to start with data and work our way up these data transmission categories and see how it maps to data networking. So first we're going to start with a website as our data. So we can have websites or email being transferred here. We're going to start with a website. We're going to assume that our user here wants to go to pluralsight.com. So she types in www.pluralsight.com into her computer, and effectively what that does is it goes and grabs Pluralsight's web page and it brings it down to the local computer where our user is working. So effectively we have a computer where our user is sitting. They say, give me the website, please. And Pluralsight.com responds with, here's the website. It is literally a document, all right, like a Microsoft Word document or an Excel spreadsheet. The website that we're getting from Pluralsight.com is a document that we're downloading so that we can view it on our local workstation. So the data here is our website. In order to get that website, though, we have to have these cues like we do in our conversation. We have to have a way of setting up the conversation, of maintaining the conversation, and tearing down the conversation when it's over. So in this case, we need some mechanism to do that in networking, and that mechanism we use is called TCP, or Transmission Control Protocol. TCP is a fundamental protocol in data networking. Understanding TCP will make you a hero someday on your data network. The more you understand about TCP, the better you'll be. And there is a crazy amount of information to be learned about TCP. We're going to start with the super simple part here and see how TCP sets up a conversation between our workstation and Pluralsight. Now, before Pluralsight.com can send us the website, and actually even before we can even ask Pluralsight.com for the website, we have to establish a session in order to begin that website transfer. And the way we do that is we send a message from our workstation before we request the website. We send a message called a SYN message, S-Y-N, for synchronization. And what that synchronization message does is it says to the web server, Pluralsight.com in this case, I want to make a connection to transfer data. And the server says, yeah, I'm available for that. So what the server will do is it'll generate a message called a SYN-ACK to acknowledge the synchronization message, telling the workstation, yeah, I'm available for transferring data. The workstation will finally respond with an acknowledgement or an ACK saying, okay, I'm about to send data. I understand that you're open to do it. I'm going to send you something. Now, if you talk to network nerds, oftentimes they will actually use ACK, A-C-K, instead of yes, or I understand, or I got it. Right? It's the nerdiest way to acknowledge conversational transmissions in real life. But this process of sending a SYN, responding with a SYN-ACK, and then responding again with an ACK, that's called a three-way handshake, and is what we use in data networking in order to establish a session so that we can transfer information. This is exactly what Homer did when he called Marge, right? He didn't do a SYN-ACK. What he did is he picked up the phone, waited for the dial tone, dialed the number, wait for it to ring, wait for Marge to answer, say hello, he says hello, then they can transfer data. We're doing the same thing here. Then we can say, oh, okay, send me the website, please. And then Pluralsight responds and says, here's your web page. So what we saw now is that we have our website that we want to transfer, but in order to transfer that website, we have to do a three-way handshake with TCP. So hopefully you can see where this is going. We're going to quickly move now into the global addressing. Well, in global addressing and networking, we use something called Internet Protocol, or IP. At this point, hopefully you've heard of an IP address. If you've not heard of an IP address, don't worry. We're going to go into the nitty-gritty details of what an IP address is, how to view it on workstations and routers. Understanding IP is fundamental to understanding data networking, just like understanding TCP is. If we look at our global layer here, we have Internet Protocol, and what that means is that we're going to give something called an IP address to each device on the Internet so that every device is globally reachable, meaning any device can communicate with any other device if they know the IP address of the device they're trying to communicate with. Now, we have a sophisticated system called DNS, or Domain Name System, that will actually act as a telephone book and convert a name like pluralsight.com into the IP address 198.51.100.80 for us. We're going to learn more about that later. For now, what we need to know is that in order for our workstation to be able to send that SYN message to pluralsight.com, it has to know the IP address of pluralsight.com. So what we do is we take our SYN message and we actually address it with a source and destination IP address, just like addressing an envelope that you're ready to send in the mail. We put a to address, which is where we're sending it to. In this case, it's pluralsight.com at 198.51.100.80. And we're sending it from my workstation, which is at 203.0.113.10. Now I have a mechanism here of sending the SYN message. And pluralsight.com can then use that global address that it received from my workstation to respond back to my workstation. And then we send our ACK telling Pluralsight, yep, we're ready to send data. Then we're going to send the data saying, website, please. And pluralsight.com will respond with the document that is the web page on our workstation. At this point, you might be saying, geez, Ross, you keep repeating this. Yeah, I do. And the reason is that all of data networking is repetition again and again and again and again and again. As a matter of fact, if you read the instructions on a shampoo bottle, it says lather, rinse, repeat. That's what we're going to be doing here in data networking, is lather, rinse, and repeating. If we can get that down pat, we have the mechanism we need to understand data networking. Let's go on to the next layer, which is our local layer here. And in our local layer, when we had a conversation, we were using our names. Here, we're going to use something called Ethernet. In Ethernet, we need local addressing. The local addressing we use in Ethernet is something called a MAC address. An Ethernet MAC address is an identifier for Ethernet communication locally. Now, in order for us to be able to send a message from our workstation to the global address at Pluralsight, 198.51.100.80, I need to take that global addressing and I need to put it in another little envelope, a container, that has my local addressing as well. So what I do here is I'm going to take my source and destination addresses, my to and from IP addresses, the global address, and I'm going to readdress that at the local layer so that my workstation can actually send the message to the device that's responsible for getting it out to the internet and eventually to pluralsight.com. And that is my router. If you have internet access at home, you will most likely have this device in your network. The device that's in your network is going to have an IP address on it, just like this one does. This one has an IP address of 203.0.113.1, and that's called our default gateway. A gateway and a router are the same exact thing. As a matter of fact, it's two different names for the same exact device. So our default gateway is where we send our messages when they're going out to the public internet. In order to get our message to the default gateway, we need to know the local address of it. So just like when Homer called Marge using Marge's global phone number, when they answered the phone, they still used their local names to talk to each other. And this is a bit similar to that because what I need to do is I need to send my message to the router using the local addressing. When it gets to the router is going to see that this message was destined for it based on the local addressing, and it's going to throw that local addressing away and put in new local addressing so that when the router sends the message out its other interface, the one that's connected to the internet, it can actually get that message locally to the next device on the internet that needs to get it. And it'll keep putting this message in new little packages with a local address in them to get from one router to the next router to the next router until we get all the way to pluralsight.com. We don't know what those local addresses are. We'll never be able to see them. They're invisible to us on our local network, and there's a good reason for that. The good reason for it is way too complex to explain now, but just understand that when we're sending our messages from one device to another device, we always have to put that message into some kind of container that has a local addressing scheme attached to it. Once we get that message to our router, then the bigger picture can start to form, because with those local addresses and putting the SYN message that's addressed globally inside of another container with our local addresses, that's what's going to allow it to propagate over the entire internet. I've taken those addresses out of here just to keep the complexity down so that we can see that we're sending our SYN, SYN-ACK, ACK. Then we can finally request the website. The website gets sent back and we can see the website. So if you look back at our categories here, we have the website that we want to transfer, which is pluralsight.com. In order to transfer it, we need to use a three-way handshake to build a session so that we can ask to have the website transferred. In order to build that three-way handshake, we need to know global addresses, which are our IP addresses. In order to use the IP address, we have to put that whole chunk of information with the to and from and the three-way handshake information, even our website, we all have to put that in a container that's addressed locally. That's Ethernet, and there we're using MAC addresses. And all of that stuff gets sent out over wires, radio, or glass via fiber optics. If we look at our very simple network here, we have a wire. Maybe we have wireless, if we're using wireless in our home. Most likely, our data is transferred over fiber optic at some point in time between your workstation and the time that it gets to pluralsight.com. So we have our wire. We use the wire to transfer our local addressing information, which contains our global addressing information, which contains our SYN message to build the session, which is eventually going to allow us to get the website. So we have our global addressing, we send our SYN, we send our SYN-ACK, we send our ACK. We ask for the website, Pluralsight sends us the website. So we need wires, radio, or glass, we need Ethernet, we need Internet Protocol, we need TCP. All of that has to be in place simply to be able to send the website. The dependencies of these pieces show up in exactly this order. In order to send the website, we need to use TCP. In order to use TCP, we have to use IP. In order to use IP, we have to have some local mechanism for communication. In this case, it's Ethernet. There are other methods for local communication. We will get into those in depth throughout this series. For now, understand that Ethernet is a very common one. It's the one that if you have internet access at home, you are most likely using Ethernet in your house to communicate with your router to get out to the public internet. And all of that local stuff needs wires, radio, or glass to communicate.